Hello Bobcats. So today we're going to be talking about linear relationships, specifically additive and multiplicative relationships. So we're going to talk about the differences and we're going to talk about what exactly they are. So let's start with this word problem here. Every state has 2 U.S. senators. The number of electoral votes a state has is equal to the total number of U.S. senators and U.S. representatives. So the number of electoral votes is, well, let's go back and look at the actual problem. Every state has 2 U.S. senators. So the number of electoral votes equals to that. So that means plus 2. So that's 2. So the number of votes is 2 more than the number of representatives. Now 2 more means plus 2. So if we look at the table, we have the number of representatives and then we have the electoral votes. So if there's 1 representative, then the electoral votes is 2 more than that. So our rule here is plus 2. So that would be 3. So the rule must be the same for every number on the table. It doesn't matter the number of representatives because it's always going to be 2 more than that. So if we continue our table, if there's 5 representatives, then there's going to be 7 electoral votes. 25, well, that's going to be 27. And 41, well, that's going to be 43. So we can now determine the rule. So we said that the 2 more was plus, and if you go back, it's 2 there, so it is plus 2. So this is an example of an additive relationship. Additive. Why? Because we are adding in our rule to help us find what we're looking for. And this is an example, like I said, of an additive relationship and can be represented by the equation y equals x plus a, where a represents any number. So if we take this equation and apply it to our rule, we would have y equals x plus 2, which is our rule for this table. Okay, so y is going to be our electoral votes, x is going to be our representatives, and then our rule is right there. So this number, x plus 2, is going to give me y. And if I apply that, so if I do, let's do 5. So x is 5 plus 2, well, that gives me 7. So yes, it works. Now let's look at it in a graph. Okay, so we're going to graph the relationships of the numbers. Now remember, we had 1 representative, 3, 2, 4. Remember, our rule was plus 2. So if we put it as a table in a T-chart, again, that was x and then this is y. So in our graph, this represents the x-axis and this represents the y-axis, always. Okay, across is x, horizontally is y. This is how it would look graphed. So x is 1, so 1 should be somewhere right here because that's 10. This would be 5, so 1 is somewhere there. And then our y is 3, which again is closer to that 5. So they just went ahead and plot everything for us. We're gonna come back to this graph when we compare it to a multiplicative graph. So let's go ahead and move on. Okay, second word problem. Franny orders 3 DVDs per month from her DVD club. Complete the table. Okay, so every month she orders 3. So the first month she ordered 3. Second month she ordered 3. Fourth month she ordered 3, and so on and so forth. per. That's a keyword for multiplication. So every month, each month is 3. So our rule is going to be times 3, times 3, times 3. So let's complete the actual table. So in 4 months, if she orders 3, then she'll have 12. In 13 months, she'll have 39. And in 22 months, she'll have 66. Okay, because every month she's ordering 3, and that would be her total as the months progress. So again, let's try to find the rule. Well, we kind of already did that. So it was times, and because it says 3 and not per, so it's times 3. This is a multiplicative relationships, and the equation for that would be y equals ax. Remember, when we have a variable next to a variable with no operation in between, that means multiplication. And again, a represents any number. So in this case, I would use y equals 3x. Again, x is the months and y is the DVDs ordered. So I can do this. So I can do y equals 3 times 4. Well, that gives me 12. And yes, that matches. So that's how I would use or incorporate my equation for this table. Alright, now let's look at the graphs of a multiplicative relationship. Again, x and y, x and y. Guys, get in the habit of always labeling x and y because that's very helpful. Okay, let's go ahead and compare them side by side. I want you to take some time and actually look at the graphs and see what they have in common and see what they have different. So again, remember, like I told you, always start by labeling your graphs. Just make this a habit, guys. Okay, so if I see here, I see that there's a x-axis and a y-axis on both. They both have plots. They both have a straight line. But the main thing that I want you to focus and look at is that a multiplicative relationship starts and always will start at 0. Versus an additive relationship will not. So if you look at the graph and you see that it starts at 0 or it goes through 0, it's automatically a multiplicative relationship. And if it doesn't, then it's an additive relationship. That's the main point that I want you to take from these two graphs and us comparing them. Alright guys,